Hello everyone, this is Abdul Wahid. In this video we will see the moment of inertia and its different types. First coming to the definition of moment of inertia. Moment of inertia is the quantity expressing the tendency of an object to resist angular acceleration. This definition is in physics, and it is the sum of the products of mass of each parts of the object into the square of the perpendicular distance from a arbitrary axis. For better illustration, let us consider the different types of the moment of inertia. The first type is the mass moment of inertia. First one is mass moment of inertia. Mass moment of inertia. In mass moment of inertia, the mass of each part of an object is multiplied with the perpendicular distance, and the perpendicular distance is square. Now, let me draw one object. Assume this is an axis and there is one object. If I divide this, let it be x-axis and y-axis. If I divide this one into different parts, like this, into different parts, and if I denote the distance from x-axis, this one has r1, distance of second part r2. Similarly, I can divide this one into n parts. Now, the mass of this part is m1 and the mass of this part is m2. Then what is moment of inertia of this one? For the first part, part of the object, I can write in this one as I1 is equal to m1 into r1 square. This is the moment of inertia for the first part of the object. And for the second part of the object, the mass moment of inertia can be written as m2 into r2 square. If we divide this one into n parts, I can write this one. In is equal to m suffix n r suffix n square. That is the moment of inertia of nth part of the object. Now, if I sum up this one, the mass moment of inertia for entire object can be obtained as I is equal to I1 plus I2 plus In. Now if I substitute those values, I will have sigma m suffix I r suffix I square. I is starting from 1 to n. This is the mass moment of inertia. Coming to the second type of moment of inertia, that is area moment of inertia, or second moment of inertia area, let's call this. Now, area moment of inertia. Moment of inertia. And area moment of inertia, different axes are considered. For example, if I consider same one object like this is the x-axis and this is y-axis. In the same way, if I divide this one into different parts, first I'm assuming only two parts. It can be divided into different parts. Now the distance of object 1, part 1, part 2. Part 1 of the object, the distance is, let it be y1. y1 from x-axis. And it is distance from y-axis be x1. Similarly, for the second part, it is distance from x-axis be y2. And its distance from y-axis be x2. Now, if I find the area moment of inertia with respect to x-axis, I can write this one as I1. Actually, I should write this one Ix1 is equal to, what is the distance, the area of the object 1, A1, into perpendicular distance from x-axis, that is y1, and that should be square. That's why it's called the second moment of area. Now, this is for the first part of the object. For the second part also, if I write this one, Ixx2 A2 into y2 square. Similarly, if I have n object, or if I divide this object into n parts, I will write In is equal to a suffix n into yn square. This is Ixx n. If I sum up this one, I will find the moment of inertia for the entire object with respect to the x-axis, and that can be written as I is equal to I1, Ixx1, Ixx2, Ixx plus Ixxn, and totally it will be sigma ai into yi square, I is starting from 1 to n. This is the important equation. Now, this is moment of inertia of the object with respect to x-axis. If I want to find with respect to y-axis also, the same procedure can be followed, and the final result will be, this is Ixx, Iyy is equal to sigma I is starting from 1 to n, and here ai into, instead of yi square, I will have here xi square. This is xi square. This is with respect to y-axis. This is the second type of moment of inertia. The third type of moment of inertia is called as polar moment of inertia. Let me erase this part and I will explain that on here. Now, polar moment of inertia. Third type, polar moment of inertia. The polar moment of inertia is the moment of inertia which is obtained with respect to the axis perpendicular to the plane. And also it is sometimes called as the moment of inertia with respect to z-axis. Let me draw this axis. That will be x-axis, y-axis, and z-axis. Now, if I assume an object is there, and it has, in the same way, it can be divided into different parts. Now, the distance of this one, the overall distance, the final distance, if this is the r, this is r, or else the r can be obtained for the small part. Let me consider this one first for the small part. For the small part, that will be r1. In the same way, the area, another one, this one also another part I am considering, small part, that will be r2. Now, moment of inertia with respect to z-axis, how can I find? Now, from this figure it's clear that the perpendicular distance of part 1 from z-axis is r1, and perpendicular distance of part 2 from z-axis is r2. Now, if I find the moment of inertia, and that is called polar moment of inertia, and that is denoted by mostly by j or izz. Let me denote it by j. Now, j1 is equal to the area of the first part, A1 into R1 square, and J2 can be written as A2 into R2 square. Similarly, if I divide this one into n parts, I will have Jn is equal to An into Rn square. Now, summing up these for the entire object, if I want to have the polar moment of inertia, I will have that one as J is equal to sigma I, starting from 1 ending at n, An into Ai into Ri square, Ri square, and this can be written as in this way. This is called the polar moment of inertia. And in some derivation, which will be derived in the upcoming videos, the polar moment of inertia, or moment of inertia with respect to z-axis, is equal to moment of inertia with respect to x-axis plus moment of inertia with respect to y-axis. These are types of moment of inertia. Here we have the three types of moment of inertia: mass moment of inertia, area moment of inertia or second moment of area, and polar moment of inertia. And these are very important to be remembered, especially the area moment of inertia, which is vastly used in civil engineering designs and calculations. Thank you for watching. Subscribe my YouTube channel. If you have any question, comment below. I will try to reply as soon as possible. Thank you for watching.